Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of predictions from simple experiments. This is standard 7.6H in the great state of Texas, and we are using item number 37 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we've got Leticia, and she's got 2 bouquets of flowers, and each bouquet contains 13 daisies. So each bouquet has 13 daisies, but you notice our bouquets are different sizes. So we've got a bouquet S. So this is definitely going to be one that needs a picture. So let me draw a bouquet of 30 flowers. What I'm going to do is I'm just going to kind of draw some stems like this. I'm going to draw them in groups of 5 to kind of keep them together. So I've got 13 daisies, so I'm just going to go ahead and just write D. So these are my daisies. I've got 5 daisies so far. Now I've got 10 daisies. Now I'm going to draw another 5. So I've got 15 so far, so I'm going to need to double that. But you notice I've only got 13 daisies, so I'm going to get 11, 12, 13. I'm just going to draw X's. X's simply mean non-daisies. So I'm just going to kind of do a little bit more. I'll say these are all part of S as well. I'm just kind of out of room there. So X, 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 X. This is all part of S. 2, 3, 4, 5. So that's a big bouquet. It's like 2 bouquets together. 3, 4, 5. All right, so what do we have here? We've got 30 flowers, but in bouquet S, we've got 13 daisies over 30 total flowers. All right, so let's look at bouquet T. That's going to be a little bit easier for us because it's just going to, just look at that. It's going to be 13 flowers, but it says each bouquet contains 13 daisies. So watch this. 1, 2, 3, 4, 5. That's daisy, 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 daisy. 1, 2, 3, 4, 5. Daisy, 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 and then daisy. Then I've only got 3 left. 1, 2, 3. There's my 13 flowers, and all 13. It's interesting. I've got 13 daisies out of 13 total. Would have been easier if they would have just said bouquet T is all daisies. But all right, let's look at our statements now. The probability of randomly selecting a daisy from bouquet S is less than probability of randomly selecting a daisy from bouquet T. Well, we can kind of put that out here. So this is 13 out of 30. That's my bouquet S is less than probability of getting a daisy from bouquet T, which is 13 out of 13. Well, we could do, a little bit of cross butterfly method to see which one's bigger, but we know that this 13, 13, this is really 1, right? That's the whole thing. So instead of that, I can just say 13 over 30 is less than 1, because that's what that is. That's 1 whole. And does that make sense? Actually, that does make sense. 13/30 is less than a whole. So I'm thinking A looks pretty good. Let's double check the rest. The probability of randomly selecting a daisy from bouquet S is 1. Oh, look at this. No. If this was bouquet T, we would be good. The probability of randomly selecting a daisy from bouquet S is 13 over 30. But if it's bouquet T, we'd be good. So they just gave you the wrong bouquet. The probability of randomly selecting a daisy from bouquet S is equal. Nope. 13/30 equals 1. Nope. Does not. So we cannot say that. And then the probability of randomly selecting a daisy from bouquet S is 1/3. Does 13 over 30 equal 1/3? And actually, no, it does not. It's a little bit smaller, so your answer here is A.